Hello, everyone. Thanks for joining us today. You're here for our prototype to production webinar. It looks like we have about 30 people online. Go ahead and use the chat over on the right and say hello if you'd like. You can chat during the webinar. I'm happy to hear from you. Hello to Dallas and Phoenix and Seoul, Korea and Brazil. So looks like we've got a worldwide attendance today. We've got about a 30 to 40-minute webinar for you guys that we think you'll be interested in. So since everyone can join and probably see from the beginning, we'll just go ahead and get started. My name is Chris Howard. I'm the founder and CEO of Softeq. And we have a webinar today for you from Softeq and Arduino. So I'll let the others introduce themselves. Fabio, maybe you're next. Go ahead and say hi.
Hello, Chris. Hello, everyone. Thank you for joining us today. So my name is Fabio Violante. I'm the CEO of Arduino, and it's a great pleasure to be with you today.
Thanks, Fabio.
Yeah.
I'm in Houston, Texas today. Where are you, Fabio?
I'm in San Diego.
San Diego, okay. Not in France or Italy. And Paul, go ahead and introduce
Yeah.
yourself.
Hello, everyone. Paul Frua, Senior Advisor with Softeq, and I'm also located in Houston, and it's wonderful to be with everyone today. Hope everyone's having a great day. Looking forward to this.
Thanks, Paul. All right, so what we're talking about today, many innovation efforts start strong but stall when it's time to move from prototype to production. So in this 30-minute session, Arduino and Softeq will share how we help teams navigate that transition from fast cycle prototyping to scalable deployment in industrial environments. So you'll hear from engineers, Paul in particular, and how we use Arduino Pro and Arduino products like Opta to speed up development, and how Softeq supports real-world production with deep integration expertise, and how teams can avoid some common roadblocks in industrial automation. So what you'll get out of this today, we'll talk about how BMW used Arduino to rapidly prototype and test next-gen vehicle concepts. You'll hear about how Arduino Pro enables flexible, scalable solutions for industrial and automation applications. What predictive maintenance looks like in practice, using Arduino Opta, and how you can reduce downtime and unify industrial system monitoring, and what it takes to move from a working prototype to a reliable, maintainable production system with insights from actual deployments. So this is all very interactive. Like I said at the top of the hour, go ahead and use the chat on the right. Please ask your questions so everyone can upvote them, and we'll get to those questions at the end. Quickly on the agenda, we've just gone through the welcome and introduction already. I'm going to talk a few minutes about our integration expertise, and then I'll turn it over to Fabio to talk about the Arduino Pro vision, and in particular, the BMW innovation story. Paul will then talk about the Arduino Opta solution that we implemented, and then we'll just have some free-form discussion about whatever comes up top of mind, and then we'll get to your questions. So the challenge, like I said, many organizations struggle to turn strong prototype into scalable, production-ready industrial systems. And it's not just about the tech, it's about that integration and that system reliability and future-proofing. So Softeq, with over 30 years of engineering expertise, has helped clients bridge that gap. We work with the innovative entrepreneurs at large Fortune 500 companies that come to us trying to do something new and innovative, as well as the smaller startups and SMBs, the entrepreneurs doing also something new and innovative that need either hardware or software expertise. Softeq's a little unique from the standpoint that we have a full stack of services all under one roof. So what that means is we can do hardware design, enclosures, firmware, mobile, web backend, AI and ML, and data analytics all under one roof. So a device like a smart device or an industrial IoT or IoT device or a wearable checks all those boxes from end to end. And often we get engaged from the prototyping stage where we have to do a proof of concept or a POC. Then we also have to do an MVP, a minimal viable product. and then take that to production with something that's scalable that can be shipped to millions of users. We specialize in those full stack solutions, from system architecture to embedded development, from cloud to mobile integration, and ongoing maintenance. Some examples are embedded systems for smart equipment and automation, or data acquisition and connectivity, scalable deployments for industrial, or predictive maintenance with sensor-based analytics, right? So open platforms like Arduino Pro power that rapid prototyping and agile product development for industrial automation. So as Fabio will get more into, companies like BMW leverage Arduino for quickly testing and iterating on next-gen vehicle concepts. And you'll hear more about that from Fabio. And then Arduino's industrial hardware, such as Opta micro PLCs, those enable modular, scalable deployments in real-world factory settings. And Paul will present a real-world example of that. So in essence, Softeq's deep integration and security and system design expertise with Arduino's flexible open hardware accelerates time to market. So this partnership helps teams move from proof of concept to robust, maintainable industrial IoT solutions, avoiding the typical roadblocks of scaling up, device management, and long-term support. So together, Softeq and Arduino are advancing what's possible, supporting clients with future-ready automation, smarter monitoring, and rapid scaling. So now I'll kick that over to Fabio, who will talk more in depth about Arduino and about Arduino's case study with BMW. So go ahead, Arduino. Fabio, take it away.
Okay. Hello, thank you very much, Chris. So, of course, I think people in the webinar may be familiar with Arduino in general, but maybe not so familiar with Arduino Pro. So I would like to give you a little bit of a perspective on how and why we got to the Arduino Pro. As you know, Arduino is rooted into the education. So at the very beginning of Arduino was in a very advanced school in the northern part of Italy, where one of the co-founders and also the other co-founders were teachers or students, with the idea of teaching physical computing, electronics to physical computing students. So a large crowd of students that were coming with different background into the school. And while they were teaching, they realized that there was a need for a prototyping platform for students that could save a lot of time and energy to them as teachers. And they decided to make it also open source. So that's basically the way Arduino and the Arduino Uno in particular started. So from there, of course, this project became absolutely very, very famous in the world, spreading to millions of people, and used by a different audience. Just to give you an idea of the sheer size of the community at this point, we counted in the last 12 months 36.7 million downloads of the Arduino IDE. This gives you an idea of how big is the community. So when I joined Arduino, I'm not one of the co-founders, but when I joined Arduino about 8 years ago, I started doing a segmentation of our market. And of course, I got a lot of surprises because I was thinking, I come from a software background. I have a PhD in software. So I came with the idea that Arduino was mainly education and makers platform. But what I realized very quickly is that there was a lot of professional companies, engineers, enterprise that were using Arduino not only as their hobby at home, but basically as a important vehicle for innovation in the companies. And we saw basically three different type of use cases for Arduino in enterprise. One dedicated to prototyping, that is, of course, the beginning of every serious project. Lot of testing application. So Arduino used as a testing automation for physical devices. And there was also a bunch of company, quite numerous company, that were using the Arduino platform, the traditional Arduino boards, also in production environment for certain type of application where the platform was suitable. From that idea, so from that inside, what we decided to do strategically was to create a specific set of products designed for professional users to basically support their journey in a more adequate way. So creating a new complete set of more sophisticated hardware and also more advanced libraries and software and cloud services to support those use cases. More in particular, let's say, when it comes to the professional line of product that is called Arduino Pro. For those of you that want to visit our website or go to Softeq, those are the boards that are black colored. So the black colored identifies our products. And we have three different categories of products in that area. So we have intelligent sensors, and those sensors are under the NICLA family. So they are stamp size sensors. We have system of modules. The Portenta family is the flagship product there, where we have system of modules with microcontrollers and also with combination of microcontroller and microprocessors. And the third family is what we call solution, industrial solution, what Paul is going to talk about in a few minutes. So the Opta family, the Opta expansions that are basically all-in-one solution that are ready to mount on the panel and start in production. So these products, of course, required a big effort from the Arduino R&D team, because we had to go from what we started as 8-bit microcontroller to much more sophisticated microcontrollers like the Portenta H7 product, for example, or the Opta product. They are equipped with a Cortex M4 and 7, so it's a dual-core microcontroller, very powerful microcontroller. So we created a stack of software that goes onto these boards that is based also on a real-time operating system behind the scenes that allow to do multi-threading and all these capabilities. So has been quite an interesting journey that brought us to be very relevant for many more audiences and customers that were looking for something that can be more professional and that can scale more. So just to give you an idea, one of the biggest sectors for Arduino that we were not aware of course, we were very naive at the very beginning, is the automotive sector. I still remember when I joined Arduino, we did the first Maker Faire event in San Mateo, and we had our first big booth in San Mateo. And I was sitting at the booth, and one of the first visitors showed up, and he said, "Oh, I am from Nissan Renault. We used a lot of Arduino products to prototype the cockpit of and the cabin of our cars." And then some other people came into the show, and they were telling, "Oh, I'm in automotive. I'm for this large German company doing cars, and we did all the prototyping of our latest generation with Arduino." So then we started digging a little bit more, because this was sort of a pattern, and we discovered that almost all the car manufacturers in the world are using Arduino. And in particular, it was a great pleasure to discover that BMW has been somehow standardizing a lot of prototyping activities on the use of a combination of Arduino products, both old products like the traditional, let's say, 8-bit microcontroller like the Arduino Micro, the Arduino Mega, Arduino Uno, etc. But also they were really benefiting from the small size of our NICLA family of sensors. So basically NICLA Vision, NICLA Sense ME, NICLA Voice. So these sensors are specialized sensors equipped with microcontroller and communication capabilities that allow to create prototypes in really hours or days, rather than having to create custom solution, custom hardware. So I visited some of their research center where they do innovation, interaction studies, etc. And it was quite impressive to see the new generation of vehicles equipped with a bunch of Arduino inside to test some whatever the engineers and all the team involved in the interaction between the vehicle and the external world we're doing. Just anecdotally, we discovered also from the BMW group that one of these prototyping activity was carried on into the Rolls-Royce Phantom car, quite an expensive car, basically, where the ceiling of the car is became very famous because it's packed with LEDs that replicate the stars. And the prototyping again has been done with using Arduino. In that case, was like the SAM-D21, the MKR family of Arduino. But then that design has been taken and used for the final version of the vehicle ceiling. So it's quite interesting to see how many different applications, but even race cars, so they are using Arduino. So this is just an example of how people can quickly prototype. This example is an automotive, but we can somehow generalize this sort of approach because we have all sorts of companies from Fortune 1000 to the small, medium shops. And it's very exciting also what Paul is going to tell you about, more industrial use cases. So I think, Chris, we can go over 4 hours here, but I need to pass the stage to Paul. Thank you very much.
Sure. Okay, that's good. And maybe Fabio, looks like Crowdcast dropped your video again. So maybe if you want to refresh your browser real quick, and we'll get you back on video. But yeah, thank you for that. And anyway, we had the AI version of Fabio on the slide while we didn't have his video. This is what Gen AI thinks Fabio looks like. But so I thought it was kind of fun to include that. Almost has those Arduino stars behind him, like you talked about. I want stars on the top of my car. I think that would be pretty fun. All right, so we'll bring it over to Paul. Paul also has an AI avatar. So Paul, you're looking good. So we'll let you I think there's Fabio, and we'll let you talk now about your case study. And
yeah,
maybe
I need to grow my beard. So
bring your beard back. Yeah, it thinks you had one.
Yeah, it thinks I had one. Yeah, I did want to make one kind of housekeeping note because it looks like some people are kind of not sure how to use the tool. So over on the right-hand side of your browser, there's a question mark in a little bubble. That's how you ask questions, right? So if you click on that, then you can submit your questions. So there's not going to be interactive talking. It seems like some people were thinking maybe they would be able to just talk to us directly, but it's typed questions. So yeah, questions are text, not audio. Thanks, Chris. Yeah, so all right, I just wanted to kind of get that out of the way. Yeah, so once again, Paul Fra, senior advisor here in Softeq, engineering background. I've been working with hardware and electronics and software for many years. The story here is, we had a client that came to us with, I guess you can go to the next slide, Chris, because it is kind of the summary here.
Probably 40 years, Paul, maybe? Is that how long?
Yeah, it's been a while.
Who's counting?
Yeah. So you're only as old as you feel, right? Or something like that. So the client came to us with a challenge. They wanted to automate food delivery. They have a kitchen where they're preparing food, and then they have people, their customers coming to collect the food, whether that's from a parking lot or a counter or whatever. And they wanted to automate the process of delivering that food using a conveyor system. And so they, one of the challenges was, they wanted to have some flexibility in deployment, ease of deployment of the conveyors. They didn't want to have a bunch of cabling and things associated, other than more or less plugging in the power. And so they asked us to come up with a wireless solution, a wireless remote control solution for the conveyor system. So, that was the main focus of the project. They also wanted to be able to monitor the system over a network. So they wanted to have some visibility into how the system was operating and functioning using a wireless network as well. And then ultimately the main thing was about flexibility, right? Being able to control it remotely, manage the system. Oh, and also be able to provide updates, to the system remotely. And so just to kind of give you an overview, what we provided to them was, Wi-Fi access to the system, for monitoring and updates and control. We also provided Bluetooth remote control, and we integrated, some sensors into the system to detect, is an object at the origin of the conveyor belt or at the destination? Is the door at the destination open or closed? That sort of thing. And then the system obviously had to control the conveyor itself. It had to turn it on and off, and it had to control the direction, of the conveyor. So Chris, you can go to the next slide, please. So the solution, for us was pretty clear from the start. I mean, that we didn't need to reinvent the wheel, right? There was something in the market that already existed, the Arduino Opta. And so it made perfect sense. It's got 8 I/O sensor inputs. It's got 4 relay controlled high power outputs. So it could definitely handle the origin and destination sensors, the door closure sensor. It could also handle controlling the power, sending power to and from, or really just to the conveyor belt, right? So it was a perfect solution. The Opta also has Bluetooth and Wi-Fi built in. So it was really kind of a no-brainer. We didn't have to do a lot other than make some minor modifications to the conveyor itself to connect the power outputs on the Opta to the conveyor. And then some minor and the sensors to the Opta, and then some minor programming to get things working. There is some logic involved in is the destination door open? Okay, don't run the conveyor, right? Is there something actually at the origin ready to go to the destination? Okay, now you can push the forward button and send the food down the line. Is there something at the is there a tray at the destination? Bring that tray back. So there was some of that kind of control that was there. But the Arduino Pro Opta was perfect off the shelf solution for this. And we use the Opta for conveyor control and the Wi-Fi Bluetooth access. And then we also use the Arduino Maker Wi-Fi 1010 for the remote control piece. So there's actually a separate box that could be mounted inside the kitchen that has, a light that shows when it's ready, and then, like forward and backward buttons that control the conveyor itself. And then the Opta is mounted in proximity of the conveyor. And the system is designed to support multiple conveyors in tandem. So again, easy configurability, easy setup. Also, the Opta's price competitive, right? It's less than $200. Easy to deploy. Really, really good solution for this client. Next slide, please.
Push. There we go.
So again, just I already covered some of this, but just to kind of give you the high level, so the Opta's already it's off the shelf available. It's already FCC, UL, EU certified, among other certifications. Reduce the hardware and firmware implementation efforts significantly. It's a rugged design. It's industrial grade, operates minus 20 C to plus 50 C. No additional cooling needed. Over-the-air updates I mentioned. The one thing I haven't mentioned was Arduino cloud integration. So that's another benefit of going with Arduino is all of their products have the ability to connect to their cloud, and provide remote programming, monitoring, and configuration. And so we were able to take advantage of that to do a quick mock-up of here's a remote control over the network, as opposed to the remote control through the box that we created. So dual functionality, dual control there.
And that's big. That's big too, because that's what happens with a lot of devices. Not only do you need the hardware and the firmware, you might also need a mobile app or something like that, but you need that
Yep.
back end cloud. And in a lot of cases, you can leverage the Arduino cloud for your application, depending on I mean, even for rollout to enterprise, right? I mean, but especially when you're prototyping, you don't need to have a back end in order to support your device, or maybe you have a limited number of devices, and you don't need to support 100,000 or 1 million devices all at once.
Right. Yeah, and the Arduino cloud is world class. It's built on AWS, so you're getting a top notch system. And I would say the biggest takeaway from all this is, this was a prototyping effort that we did for this project, but there's really no difference between this and production. I mean, he's essentially going to be able to take this solution directly to production, and it just because of the Arduino Pro, because of everything that Arduino's done to make it simple and easy to implement, and providing a enterprise grade solution, made it a perfect fit for this project.
All right, thanks, Paul. Yeah,
sure.
So let's just talk a little bit after all that presentation. So there's a lot of broad depth and experience and product to leverage in development, where you don't have to start from greenfield. So not only can you prototype your hardware and also leverage tools like Arduino Cloud to test out your concept, but you can actually go to production with that. And there's been a perception for a long time, right, Fabio, about how a lot of people, viewed Arduino as really only for prototyping, or maybe only for hobbyists. And that was one of your impetuses for rolling out the Arduino Pro line, right? So that instead of having to go from an Arduino platform to, say, something like Qualcomm, although no, that's all in the family, you now have options where you can go to an enterprise solution with an Arduino Pro. Maybe touch a little bit about that, on kind of how that fits in now, and especially with your recent acquisition by Qualcomm. Congratulations, by the way, since that just finalized like a week ago. Yeah, tell us a little bit more about that.
Yeah, so basically, I think Paul explained very well the principles behind what we do, why we did like the Arduino Pro family of products. So the idea is that sometimes people want a solution that just work, to just they're familiar with. There is always and more in small medium enterprises, this sort of lack of resources to do complex projects. So what we try to do is to provide tools that make complex solution really easy to access, so that people with no experience, little experience, but even our system integrators and our partners like you, of course, prefer to work with things that add value from the functional point of view to the customer business, rather than just having to do boilerplate code and to replicate and do a lot of waste and energy just to make the system work. So that's the reason we created those abstractions, including the Arduino Cloud. This is my baby, because I'm also one of the biggest users of the Arduino Cloud at the individual level. So the Arduino Cloud attempt was to create a digital twin that can be easily accessed with the same spirit. So you don't have to have a PhD in computer science to just get a machine connected to the internet, connecting power data, controlling the machine, etc. So this is the principle that guided the entire philosophy here. So touching upon Qualcomm, I don't know. So you ask also about Qualcomm. Of course, we
Tell me a
are
little bit
very
about how you see that kind of fitting, because it kind of
absolutely.
assembled the whole stack between Arduino, Edge, Impulse, Foundries, and then Qualcomm is all like under this umbrella. That's what we saw at Embedded World last week.
Yeah, exactly. So the basic idea of the Qualcomm acquisition is to sort of, for us, bring a new AI muscle and democratize more sophisticated technology that we were looking for. And of course, while respecting the spirit of Arduino. So the idea is that Arduino remains Arduino and add more value for our customers. So far the journey has been really interesting. I don't know if you had chance to play a little bit with the Arduino Uno Q that we launched together with Qualcomm, was our common
I think
product.
Paul got one. He got his ordered. I don't know if he's had time to play with it yet, but
Yeah, I've been traveling the last 2 weeks, so yeah, I'm excited, but I haven't had a chance to even break it out yet.
It is quite impressive. So basically, just to testify that that product is completely open source. You have Gerber schematics, everything, documentation. The source code is mainline Debian distribution. So it's an innovation for Qualcomm, but it's something that will give you an idea of how the future will evolve. So basically, very excited about this acquisition, honestly.
no, we're excited too. I mean, we're a Qualcomm partner, and we've of course been working closely with you guys now for a number of years, and so we see great potential in the better together, and that Qualcomm is supporting this maybe a little more entry level, and it's smaller, at least initially, development projects that might come through the pipeline, and every project starts small and then gets to the scale that that maybe Qualcomm is used to, but and then the ability to add AI to edge devices as well, and leveraging like Edge Impulse, I think is exciting, where you don't have to, you've got a partner to do development, us as well, where we can bring them in, and again, not having to say greenfield and AI development at the edge, and leveraging their expertise and in implementing AI solutions on device. I think it's pretty exciting. Everything's going to get smarter, out there. Every device is going to get smarter. So maybe we'll, since we're coming up on maybe about 30 minutes here, we got a couple of questions. Looks like one here at the top. How do you ensure that a prototype built on Arduino Pro can scale reliably to an industrial grade production system? Paul, if you want to touch on that, or maybe Fabio. I think it's the point of Pro, right? Is that it already is industrial grade, right?
Yeah, exactly. So the entire idea behind the Pro line was exactly to enable people to scale. So more compact form factor, more professional, let's say, microcontrollers, uh, different temperature range. So the idea is you have a way to prototype, even friendly ways to prototype. For example, for the Portenta line of system of modules that we have, we have a companion that is the Arduino Giga, that is in the form of Uno. So if you want to do breadboarding and all these things, you have the same microcontroller, the same code base that you have there. You can translate it into the Portenta. So exactly, the idea is to create modular solutions that can scale. These are different board compared to the traditional Arduino boards in terms of also end of life kind of things. So all the typical parameters for industrial application, so that we can ensure supply of these components, etc. So the philosophy behind that is exactly the one.
Mm-hmm.
Well, and I would just add, Fabio, what you guys have done is you've built on industry standard microprocessors, right? So you're using, processors from ST Micro and Qualcomm and
Yes.
and Renesas and others, right? So if you prototype using Arduino, or you you build your MVP on Arduino, and then you need to scale. If for some reason you need a custom design, you're really set to go, right? You don't have to do a whole lot of rework. You just maybe do a custom board, so, and then you get to production really quickly. So it's really very easy to go from prototype to production, right?
Maybe talk about, I know we just touched on it. Probably most people don't know what the Uno Q is. Maybe you can talk a little bit about that, Fabio. What is the Uno Q?
So the Uno Q is a new board that is designed with the principle of having a dual brain architecture. So it's still a very powerful microcontroller, typical Arduino microcontroller. In that case, is a ST Micro device, is the U5 from ST Micro, but it has a companion, like a large companion, that is a Qualcomm microprocessor. Is a quad-core microprocessor with 2 GB of RAM, and this combination is interesting because we created a communication mechanism between the microcontroller and the microprocessor. So if you saw, the online campaign was called From Blink to Think, because the idea was to combine thinking capabilities, so more sophisticated, let's say, capabilities, and the real-time aspect through the microcontroller. So you can create really interesting solution where you may need like some Python code or some AI that runs into the Linux machine, combined with the ability to run motors, CAN bus drivers, and all these things for the real-time part. And compared to the Arduino Uno, it shares the form factor with the Arduino Uno, so he is compatible with the Shields ecosystem from the Uno. But at the bottom, it has two what we call mid-density connector that break out the connectors for external camera. You can connect two cameras to this board. You have also MIPI DSI, all these type of interfaces for the product, so that you can drive displays. It is also USB-C that is full video enabled, and you can attach video a monitor, you can attach keyboard, and you can develop on the board as well. So the other thing that is interesting, sorry for the long explanation, but the other interesting aspect is that we introduced a new development environment. Of course, the board can be programmed also with the Arduino IDE, the traditional Arduino IDE, but we created a new development environment that is called Arduino App Lab, that combines the microcontroller programming capability, Python, AI model, and the management of containers on the board, all in a very seamless, like you do with the normal Arduino. When you open the example, you start from an example, but then the example is a piece of code that goes into the microcontroller, and the other one that goes into the microprocessor, and the AI model that goes either on the microcontroller or the microprocessor. So it's quite interesting concept that we're going to push forward in the upcoming months.
Yeah, it's very, very exciting product. Thanks for the overview. All right, so maybe one more question here. What are the biggest challenges companies face when moving from a working prototype to full-scale production? I think that with any prototype, I mean, if you're doing it right, you are cutting corners, right? You're just trying to get basically a proof of concept out there to see if your idea actually works. You're trying not to spend too much money on the hardware, too much money on the software, too much money on the back end until you figure out whether this is actually going to work or not. Once you figure that out, now you need to, make it enterprise ready, right? Which generally means, designing maybe a better enclosure for the device, because you don't usually worry about it. You say Frankenstein board all over your desk, right? Or maybe it's a small piece or a stack that's not something that can be put into a form factor or a wearable, and now you need to make that a shippable product. And I would think the other challenge is the reliability, right? So meaning that you need to you need to do more QA on your full scale production device before you send it out to 100,000 users or 1 million users. You're going to have to do more testing, which is going to involve hardware testing, firmware testing, maybe mobile and backend testing, depending on what you're using. Paul, any other thoughts that you can think of as far as moving from prototype to production? Maybe the porting. I mean, in the past, it's been porting. You'd had to move from, like, say, an Arduino processor to a different micro, right? And so now you're kind of starting over in firmware development. Now you don't necessarily have to do that.
Yeah.
Anything else you can top of mind? Oh, okay.
No. Sorry.
Bobby, anything? No, that's fine. This guy, I checked all the boxes.
Yeah.
Yeah, no, I think you covered the most important aspect. I think the continuity that we can provide with the Arduino Pro is very important because every redesign can introduce new errors. They can be at the hardware level, they can be at the firmware level, etc. So I think you stressed a lot the testing aspect and the Q&A aspect. That's very, very important, of course, because in prototyping, sometimes you try to solve a problem. When you go to production, you have to solve all the problems.
Yeah. Well, and then also not having to throw all that away. I mean, sometimes, yeah, you're trying to do something rapid and prototype, and you prototype it, and then now you're going to go over here, and now you've got different hardware, and you got to write different code, and you've got a different processor, and you have a whole new stack of bugs, and you also have to take a step back, right? And so with this method, you actually are halfway there or more toward a production ready solution, being able to use Arduino Pro to move forward, or something like the Uno Q. All right. Well, I think we're at 45 minutes. We said this would be about 40. We have one question here about real world examples of prototyping future consumer electronic products. I don't know if anything top of mind for you, Fabio, besides automotive. Anything interesting?
Yeah, no, absolutely. So we have plenty of examples. So it really depends on what we consider to be consumer electronics, but basically we have example in every area. Just to give you an idea, one of the biggest and most expensive power amplifiers brand in the US is using Arduino for prototyping their amplifier. But then going to more like, let's say, more modern, I would say, devices. That we introduced the nano matter because in consumer electronics it's very important, the matter protocol, because it's sort of the lingua franca for making devices talk to each other, and it's a partnership with Silicon Labs. And this product is used a lot to prototype consumer device that are connected to Matter via Thread protocol and Bluetooth. So we have really countless example. Just I cannot make the name, but for example, there is a power tool company in the US, very famous one that is doing.
I could tell you the color, but it would give it away.
So they are doing a lot of prototyping. They extended, so they are using Arduino in an interesting way. So basically, they are using Arduino to engage also not only electrical engineer in doing a ideation of products, but also a broader community, because through Arduino they can somehow lower the barrier to entry to technology. So other people from the design team, from the industrial design team, for example, or the creative team, they can contribute by adding features and functions to those tools in a way that maybe the engineers never anticipated, because they are they have the needs, and they didn't have the tools to understand how to add those capabilities. So it's quite interesting because you can create a new generation of ideation volano. So that's very interesting. The what flywheel, let's say, the flywheel effect of a new idea generation.
Yeah.
So ton of examples.
I saw that. I was pretty surprised actually when I saw that at the developer conference last year, and pretty interesting what they're doing and how they've enabled their engineers to kind of ideate and innovate and prototype, and then that makes it into the tool products. All right, so let's wrap up. Thank you for joining us today. Thank you, Paul. Thank you, Fabio. And thank you, audience. If anybody has any more questions, needs, prototypes, production, anything you want to know about Arduino or hardware, software, etc., feel free to reach out to any of us or look on the softeq.com or Arduino websites, and we'd be happy to answer your questions further there or help you out. So have a great week, everyone, and thanks for joining us today.
Thank
you very much.
Bye.
Thanks, Fabio. Good seeing you guys.